Bismillahirrahmanirrahim. This is lecture number 11. Our topic is mensuration. This is part 1 of our topic. Mensuration means measurement. In order to measure length, breadth, perimeter, area and volume of geometrical figure, we say it is mensuration. We can categorize two-dimensional figures as quadrilateral, four-sided closed shape. Examples are square, rhombus, rectangle, parallelogram, trapezium, etc. Number 2 is triangles, three-sided closed shape. Examples are right angle, isosceles, equilateral and scalene triangles. Circle, close round shape, we will learn semicircle, arc, sector and segment. Now we are going to discuss about perimeter and area of two-dimensional geometrical figures. Number 1 is quadrilaterals. Square and rhombus have many similarities. If we press a square from top, then it becomes rhombus. All sides of a square are equal, that is S, S, S and S. All sides of rhombus are equal, that is S, S, S and S. All sides of a square intersect at right angle as shown in figure. All sides of rhombus do not intersect at 90 degree as shown in figure. Diagonals of a square are equal, that is D1 is equal to D2. Diagonals of rhombus are not equal, that is D1 is not equal to D2 as we can see in figure. Here D1 is greater than D2. Perimeter of a square is equal to S plus S plus S plus S is equal to 4S. Perimeter of rhombus is equal to S plus S plus S plus S is equal to 4S. Area of square is equal to S multiplied by S is equal to S square. Area of rhombus is equal to 1 upon 2 D1 multiplied by D2, or if B is equal to base of the rhombus and H is the height of the rhombus, so area of rhombus is equal to B into H, means base into height. So area of rhombus is equal to base into height, that is B into H. Rectangle and parallelogram also have similarities. If we press rectangle from top, then we get parallelogram as shown in figure. In rectangle, opposite sides are equal and parallel. In parallelogram, opposite sides are equal and parallel. All sides of rectangle intersect at 90 degree. All sides do not intersect at 90 degree in parallelogram as shown in figure. Diagonals of rectangle are equal, that is D1 is equal to D2. Diagonals of parallelogram are not equal, that is D1 is not equal to D2. Perimeter of rectangle is equal to L plus B plus B is equal to 2L plus 2B. Perimeter of parallelogram is equal to L plus B plus B is equal to 2L plus 2B. Area of rectangle is equal to length into breadth, that is L into B. Area of parallelogram is equal to base into height. Next shape of quadrilateral is trapezium. There are three types of trapezium: right angle trapezium, isosceles trapezium, scalene trapezium. Right angle trapezium has two opposite sides are parallel. Two parallel sides intersect at right angle as shown. Isosceles trapezium has two opposite sides that are parallel and other two opposite sides are equal. Scalene trapezium has two opposite sides are parallel. All sides are unequal as shown in figure. Perimeter of any trapezium is equal to sum of all sides. Area of any trapezium is equal to 1 upon 2 into sum of parallel sides into height. Next category of shapes is triangle. First shape triangle is right angle triangle. It has one angle equal to 90 degree as shown. Base is shown in figure denoted by B. Height is shown by H. Hypotenuse is shown by capital H. Therefore, perimeter is equal to base plus height plus hypotenuse. Area of right angle triangle is equal to half base into height. Next shape of triangle is isosceles triangle. Two equal sides, opposite angles are equal as shown. Equilateral triangles have all sides are equal and all angles are also equal, that is equal to 60 degrees each. Scalene triangles have all sides are unequal, all angles are also unequal. So isosceles triangle, equilateral triangle and scalene triangles are other than right angle triangle. Therefore, perimeter of any triangle is equal to S1 plus S2 plus S3. Area of triangle other than right angle triangle is equal to 1 upon 2 multiplied by AB sine C, that is angle between the sides of A and B as shown in figure. Next category of two-dimensional geometrical shape is circle having radius is equal to r. Therefore, the perimeter of circle is also known as circumference of a circle is given by 2 pi r and area of circle is given by pi r square. Next shape of circle is semicircle having radius r. Perimeter of a semicircle or the circumference of a semicircle is equal to pi r plus r plus r is equal to pi r plus 2r. Area of semicircle is equal to pi r square divided by 2 because it is a semicircle. Arc length is equal to theta upon 360 multiplied by 2 pi r. So perimeter is equal to theta upon 360 multiplied by 2 pi r plus r plus r. Therefore, perimeter is equal to theta upon 360 multiplied by 2 pi r plus 2r. The chord of a circle can be defined as the line segment joining any 2 points on the circumference of the circle. It should be noted that the diameter is the longest chord of a circle which passes through the center of the circle. Sector. It is the portion of area of a circle under the arc and two radii of circle as shown in figure. area of a sector is equal to theta upon 360 multiplied by pi r square. What is a segment? This is the arc of a circle. The chord of a circle is also shown in figure. Therefore, the segment is the area under the arc and the chord of the circle. Therefore, area of segment is equal to area of sector. The sector is also shown in the figure. Now back to formula. It is minus area of triangle. The shaded portion of triangle is shown in figure. The angle is denoted by theta. The sides of triangle are actually the radii of a circle equal to r. Therefore, the formula will be theta upon 360 multiplied by pi r square minus 1 upon 2 multiplied by r multiplied by r multiplied by sine theta. Because we know that area of triangle is equal to 1 upon 2 AB sine C. Therefore, area of segment is equal to theta upon 360 multiplied by pi r square minus 1 upon 2 r square sine theta. Now we are going to discuss perimeter, volume and surface area of 3D geometrical figure. Number 1 is cube. Drawing cube with the help of squares as shown in figure. So cube is actually squares in 3 dimension. Since a square has all equal sides, so cube also has all its sides equal and is denoted by S. The length of base is denoted by L, breadth as B and height as H. Therefore, volume of cube is equal to L into B into H is equal to S into S into S is equal to S cube. We noticed that there are 6 squares in cube. 2 is denoted by top of cube. 1 is base or bottom. 3 is right side of cube. 4 is left. 5 is front. And 6 is back of cube. Now drawing 1 base of a square, 3 as right side of a square, 4 as left side of a square, 5 as front, 6 as back and 2 as top. Therefore, surface area is the sum of area of 6 squares. Therefore, surface area is equal to 6s square. So the combination of 6 squares drawn separately is known as nets of solid as shown. Therefore, volume of cube is equal to S cube. Surface area is equal to 6s square. What about perimeter? How many sides does this cube has? If we start counting the number of sides of cube, that is 1, 2, 3, 4, 5, 6, this is 7 and it is 8, it is 9 and here is 10, after that it is 11 and the last one is 12. Therefore, there are 12 sides, or in other words 12 equal sides. So perimeter of cube is equal to 12s, or in other words 12 equal sides because of cube. So perimeter of cube is equal to 12s. Now another 3D figure is cuboid. It is combination of rectangles in 3 dimensions as shown. The base has length L, breadth is equal to B and height is equal to H. Therefore, volume of cuboid is equal to L into B into H. Perimeter, here we can see that there are 4 lengths denoted by L. So perimeter is equal to 4L plus. Now if we see the cuboid, then there are 4 breadths as shown. So perimeter is equal to 4L plus 4B. Now again, if we noticed the cuboid, there are 4 heights. Therefore, the final formula of perimeter of cuboid is equal to 4L plus 4B plus 4H. Now working about the surface area of cuboid, if we shade the front and back rectangles of cuboid having length is equal to L and height is equal to H as shown. So there are 2 similar rectangular faces having surface area is equal to L into H plus L into H is equal to 2 bracket L into H. Now another similar set of rectangles having breadth B and height H as shown, left and right side of cuboid as circled and shaded as shown. So 2 rectangular faces having surface area is equal to B into H plus B into H is equal to 2 bracket B into H. Now another similar set of rectangles having length is equal to L and breadth is equal to B on the top and bottom of cuboid is shaded as shown. So rectangular faces having surface area is equal to L into B plus L into B is equal to 2 bracket L into B. Therefore surface area of cuboid is equal to 2 bracket L into H plus 2 bracket B into H plus 2 bracket L into B. Therefore, to sum up the formula for cuboid, looking back the previous slide, volume of cuboid is equal to L into B into H. Looking back the previous slide again, perimeter of cuboid is equal to 4L plus 4B plus 4H. Now again looking back the previous slide, we have surface area is equal to 2 bracket L into H plus 2 bracket B into H plus 2 bracket L into B. Now working for nets of solid. This is the base and it is the top of cuboid. Now drawing separate rectangles. First rectangle is the base of cuboid having length is equal to L and breadth is equal to B. Now drawing another similar set of rectangles, right and left, having breadth is equal to B and height is equal to H as shown. It is noticed that the breadth of base and breadth of right side of the cuboid and the left side of the cuboid should coincide with each other. Another similar set of rectangle in front and back of cuboid having length is equal to L and height is equal to H. Both the rectangles are drawn in such a way that length of base and length of front and back side of the cuboid coincide with each other as shown. The last rectangle is the top of cuboid under the front side of cuboid, keeping their length is equal to L and breadth is equal to B. Coincide with each other, so it is the nets of solid of cuboid. We are discussing about perimeter, volume and surface area of 3D geometrical figures. Our next figure is cylinder. It has 2 parallel circular bases. One and 2 as shown, some distant apart, and a curved surface area. This is a curved surface area. Here R is equal to radius of circular bases. H is equal to perpendicular distance between 2 bases. known as its height. Therefore, volume of the cylinder is equal to pi r square. This is circular base and its area is equal to pi r square multiplied by h. Therefore, curved surface area is equal to, this is curved surface is shown is equal to 2 pi r h. Therefore, volume of cylinder is equal to pi r square h. Curved surface area is equal to 2 pi r h. It is open from top and bottom as shown. Surface area of open cylinder is equal to 2 pi r h plus pi r square. Closed at the bottom. Surface area of closed cylinder is equal to 2 pi r h plus pi r square plus pi r square. This is closed from top and bottom. This is equal to 2 pi r h plus 2 pi r square. Next shape of 3D figure is cone is shown in figure. Cylinder is also drawn as shown. R is radius of cone and radius of cylinder. H is the height of cone and cylinder. Now what is the volume of cone? If we pour full water in the cone as shown, having radius is equal to r and height is equal to h, and then the same quantity of water is poured into the cylinder having same radius is equal to r and height is equal to h, then the water occupied in the cylinder is 1/3 of the volume of the cylinder as shown in figure. Therefore, volume of cone is equal to 1/3 into volume of cylinder. This is equal to 1/3 into pi r square h. Here in the cone, r is the radius, h is perpendicular height, L is slant height of cone as shown. Curved surface area of cone is shown in figure is equal to pi r L. If the cone is closed, that is closed from the top as shown, then total surface area of closed cone is equal to pi r L plus pi r square, where pi r square is the area of circular base at the top of the cone as shown. In the end of this lecture of mensuration part 1, different slides are made to summarize about their shapes and formula. The first slide contains a square, rhombus, rectangle and parallelogram. The second slide is about trapezium, their types and their formula. Next slide is about triangles, their types and their formula. The next slide is about circle and semicircle. Next slide is about sector, arc length, perimeter of sector and area of sector. Next slide is about segment, the area of segment, and then the next slide is about cube, its formula of volume, surface area, perimeter and nets of solid. Then there is a slide containing cuboid, its formula of volume, surface area, perimeter and nets of solid. Then the next slide is about cylinder, its volume, curved surface area and surface area of closed cylinder. Then The next slide is about cone. Its formula of volume of cone, curved surface area, and total surface area of closed cone. So it is important to learn and understand the formula and their shapes, and also the visualization of 3D shapes. And it is quite important to build the formula of their own after having a good understanding. This is the end of this lecture. If you have any question, then please ask me in the comment section. I will respond it. Till then, Allah Hafiz.